Welcome and warm greetings. Today I'm going to go over some of the features of my Chroma Sense plugin for Unreal Engine 5. Originally, I made this as a tool for stealth in one of my personal projects. However, I found a lot of people were asking me how it was done and if I could make a plugin for them based around it. What you're seeing is the example project provided on the Fab Marketplace. This AI character will chase you around the map, only moving when it is in the camera's field of view, not obstructed, and bright enough to be seen. When the AI gets close enough to the player, it will boop them, resetting to another random part of the level, pausing for a moment, then resuming its logic. For this sample, there is a cap of 6 AI, but there has been success with many more. When the game is packaged and running in a development or shipping configuration, I've been able to double and triple that number with no issues. This next section is a demonstration map for some examples. The arrow shown here is the debug actor that gets the brightness and color of the pointed location. When moved into a dark area, the brightness value, a float of 1.0 to 0.0 shown above, is reduced. A value very near 0 means that the spot is not being illuminated by any light. As you can see, when the lit debug actor is moved on top of the red square, it will still return the value of the actual brightness of the light. The unlit method, however, will not get any lighting data at all. It will return the material color of whatever object is underneath it. This method works for any transform or angle. When the debug actor is placed askew, it will get the lighting surface data of that angle as shown here. Here is an example of how this could be used for gameplay. When the player enters this area, they can only move if the light below them is closely matching green. This trigger volume enables the red light green light method, which uses the async get brightness function to check and return the color where the player is standing. Next up are the functional test examples. Each of these is designed to showcase and test a feature included with the plugin. First, we have the light color checker, which will make sure that the expected light color matches the test case. Next, this test checks for an expected light value using dynamic lighting. It will test both the async method and the static method with default parameters. This is important to ensure that both methods will return the same data each time. Similar to the previous test, this will check the expected light value, but with lumen or software ray tracing. All of these next tests have to do with camera line of sight, whether it's to a location or object. It will verify if the line of sight functions will accurately return what we expect. This last test will check to make sure that the unlit method will return the expected color, and the function checks to see if they match the array we've set. These blueprint nodes are for the AI in the example demo project. It uses both the line of sight functions and the async get brightness functions to perform its task. This is then run as a blueprint service loaded into the behavior tree and run every 0.03 of a second. Finally, here are the settings for the Chroma Sense plugin. The max active threads are the number of different captures that can be active at once. The capture resolution is the number of pixels to analyze from the capture component. More of these will lead to a more accurate brightness and color capture, but will also mean that it is exponentially more expensive. The field of view is how wide the capture for the Chroma Sense is. The higher the field of view, the more you can see, but the less accurate the brightness detection is. The brightness threshold is used to determine if a pixel is bright or dark. This typically should be left as default. The millisecond capture delay is the time between subsequent captures on the same thread. This prevents the capture from being called too often. For most cases, this can be left as default. The always persist rendering state should be turned on if you need to use lumen or virtual shadows. There is little to no performance impact, but you may end up analyzing the same pixels again if you use the async get brightness function. These are only for debug shapes and lifetimes. These are only used if the cs.debug values are set. Thank you for watching. If you have any questions or suggestions, feel free to leave a comment or reach out. I'm always wanting to improve features and make my plugins better.